Hello, this is IK Tutors, and we have another problem to do. This is from algebra, and we're dealing with quadratic equations, and we're being asked to use the technique completing the square to solve a quadratic equation. So let's get started. So we see here that we have the equation they've given us, which is s squared plus 5s equals 14. Right. So what we're going to do is whenever we see this term completing the square, we have to first understand what that means. All it means is that the equation they've given us is missing the c value. If you can see this, we have the general form of the quadratic equation here. This is the general form, right? And there are three terms, and they equal 0. Ax squared plus bx plus c equals 0. The equation that they gave us has two terms, and it equals 14. So we're going to complete the square, which is just to compute that missing value of c, because we're missing a value of c here. So we're going to compute that missing value of c. And what are we going to use to do that? We're going to be using the given value of b. In this equation, we see that b is 5, matching up with the general equation. So completing the square is simply computing, or I should say adding the value of c. Adding the value of c to the equation. Adding the missing value of c to the equation. And this is a c in the general equation, ax squared plus bx plus c. That c term, right, to the equation. Okay, so how do we do that? We use this formula here. The c value equals the b value divided by 2 squared. And we're going to pick the b value out of the equation that's given. We said we look at it, we compare our equation to the general equation, and we see that the value of b is 5. So we're going to go ahead and put that in the table. Now, why did I put a table here? Because we usually do these in clusters, in groups, right? We do about 5 to 7 at a time. We list all the b values, and then we compute all the c values, and then we go ahead and add them to it, right? So now that we've gotten the b value, we're going to go ahead and plug that b value into the equation and compute the c value. So c equals, and we see the formula up top here, b over 2. So here our b value is 5 over 2 squared. Okay, now we're going to check inside the brackets here. If this is a number that can be simplified to a whole number, then we're going to simplify it. If not, we're just going to use it as is. In this case, 5 over 2 cannot be simplified to a whole number, so we're going to use it as is. And this is our c value. So now we're going to complete the square by adding that c value to the equation. So we're going to say plus, open bracket, 5 over 2, close bracket squared. In that format, we're not going to square it. We're just going to put it exactly in with the brackets and the square and everything. And then remember, whatever operation we do on one side of the equal sign, we must do the identical operation on the other side equal sign. So we're going to go ahead and add that c value on the other side as well. So on the other side, it's 14 plus 5 over 2, close bracket squared. So we've added that c value to both sides of the equal sign. And now we're going to go ahead and factor. Now, why are we factoring? It said to solve. Why are we factoring? Because in order to solve any quadratic equation, we must first factor, right? That's the step in solving, is factoring. So we're going to factor this first. And this factors out to 1 term squared. Now, why are we squaring it? Because we used a computed c value. That, when we added that to the equation, we created what's called a perfect square trinomial, which means that its factors are going to be identical. So instead of writing 2 brackets like we normally do, 2 sets of brackets, like one here and one here, the factors are identical. So we write 1 set of bracket and we square it, right? Now we're going to go ahead and we're going to factor this. And again, because it's a perfect square trinomial, it's very easy to factor. We just take the term, which is, what's the term for this? It's s. The variable, I should say. What's the variable for this? Is s. And then we take the number and the sign from inside the brackets here where the C value is, and that's going to be a plus 5 over 2. And there you have it. We're factored. Okay. Now we factor that, we're going to simplify the right side, and then we'll be ready to solve the resulting equation. So to simplify this, it's going to take a few extra steps because it is a fractional result. So we have to remember our rules for fractions. Okay, so the first thing we're going to do is whenever we have a fraction in an equation, we have to make sure all the numbers are in fractional format. So we're going to put a 1 over this 14, underneath this 14, excuse me, and that will take care of the fractional format requirement. Now what we're going to do is this 5 over 2 is inside of a bracket, and that whole thing is squared. So that means that this is going to be 5 squared over 2 squared. So 5 squared is 25. 5 times 5 is 25. And 2 squared is 4. So now we've taken care of that. We don't need to have the brackets. All right. So now we're just adding two fractions. Okay. And remember the rules for adding fractions is that we have to have the same denominator. So we have to find the largest common denominator that both the numbers, the denominators, the numbers in the bottom go into. Well, 1 goes into everything. So we can use the largest number we can use that 4 can go into is 4. So our lowest common largest common denominator is going to be 4, right? I'm sorry, it should be the lowest common denominator, not the largest. The lowest common denominator is going to be 4. It's the smallest number that both of these numbers can go into. All right, so now we're going to rewrite both of these fractions in equivalent forms using a denominator of 4. Because that is our lowest common denominator, our LCD. Right. So the second fraction here, 25 over 4, we don't have to change anything. So we can just keep that. However, for the first fraction, 14 over 1, we have to get an equivalent fraction with a denominator of 4. And how do we do this? In order to get equivalent fraction, all we have to do is multiply the numerator and denominator by the same number. So we just asked, what number do we multiply 1 by to get 4, right? 1 we got here. We multiplied that by what to get this denominator here, 4? We multiplied it by 4, right? So we multiply the denominator by 4 to get an equivalent fraction. We simply multiply the numerator by the same number. So we're going to multiply the top and bottom by 4, right? So we multiply 4 times 14, and we get 56. Now we have the same denominators. We can go ahead and continue adding the fractions. We know that the next step is when we're adding fractions, we're going to keep the denominator and we're going to add the numerator. So 56 plus 25 is 81. All right. Now we bring down what's on the left side. It's 5 over 2 squared. Not S. It looks like an S, but it's actually a 5. Plus 5. There we go. All right. Now we're going to go ahead and solve this. So at this point, we're finished the factoring, right? This is our result. Now we're going to go ahead and solve. Right. So how do we solve an equation like this? We do the same thing we always do. Whenever we're solving, we use the opposite operation, right? Our variable is here S, right? We see that there's a squaring here. The opposite of squaring is taking the square root. So we're going to take the square root of both sides. And when we take the square root of the number, we always have to remember to put this plus minus first, and then we take the square root of the number. Now, the left side, the square root of S plus 5 over 2 squared, really simplifies because the square cancels out with the square root, so we just get what's inside the brackets, which is S plus 5 halves equals plus or minus. Now for a square root of a fraction, it can be simplified to just separating the fraction the square root and top and bottom. So we get the square root of 81 over the square root of 4, which just gives us 9 over 2. So it's plus or minus 9 over 2. Now we go ahead and solve this like we We look again on the variable side equal sign, and whatever operation we're doing, we're adding 5/2. We're going to subtract 5/2. And whatever operation doing one side of the equal sign, we're doing the same on the other. So we're going to subtract 5/2 from the other side as well. Right. Plus and minus 5/2 cancel out. We get S equals. Now we can't add these two numbers because this plus minus makes it different terms. They're not like terms. We just have to write them out. We're going to write the number first. So it's going to be minus 5/2. And then we're going to put the plus minus part last. We always put the plus minus part last. It's plus minus 9/2. And this is our answer. Okay, so I hope that helped, right? If it did, please remember to like and subscribe, and I will see you on the next question. Have an amazing day.